Okay, thank you, and bonjour and apologies. Being a typical English person, that is about the extent of my French. So I'm from Tenable. I'm obviously based in the UK, and I've popped over on the train this morning, popping back tonight. Okay, great. Should have. I'm not sure we'll even take that long to be fair. I won't subject you to too much of my English. So, setting the scene a little bit, I pulled a couple of examples of some, recent breaches, and the sources are on here as well, that talk to, most of these were related to things like open S3 buckets within AWS, which is a fairly common source of security misconfigurations. And it really sums up the kind of vulnerabilities that Tenable are looking to help our customers address. Now, why is that happening? Clearly, it's not because people are configuring this stuff through the AWS user interface, and there are similar processes in Azure and in GCP as well. If you generally go and try and configure something, like for example here, a wide open S3 bucket, it does pop up and say, do you big red triangle, right? Do you really want to do that? It's probably not a very good idea. But the fact is that people aren't really configuring things in that way, right? As we're here to talk about today, this is all about infrastructure as code and automation and orchestration. That's just some example, very simple Terraform code that will create an S3 bucket. And that's the kind of thing that you would want to see. Block public policy equals true. So, that's fairly good. But, that could quite easily be the opposite, right? If that was set to false, then that bucket would be open, potentially then any data in that would be exposed. And the point is that by automating and orchestrating the configuration of these things, at speed, and at scale, people aren't doing it through the user interface. They're doing it through code such as this. And so that's how, these things can very easily slip through, and you can wind up with a simple misconfiguration. It's a simple value that is wrong in here. Everything works, and we're testing, everything works as the application would expect it to. But a little value like that being wrong could cause the bucket to be open, can then cause data to be exposed, and then before you know it, you're on the front page of the tech. I picked the well-known English tech press. I'm sure some of those examples, make sense to you here as well, or the French, press as well. Now, are people familiar with Tenable and Nessus? No? So, so Tenable, so we've been around in the security space for over 20 years. Most widely known for this tool called Nessus, right? It is the de facto network scanning tool, commonly used by consultants, penetration testers, etc. It's basically a network reconnaissance scanning tool. The reason I wanted to put this here is just to set the scene a little bit, is because it's more suited to traditional infrastructure, sweeping IP address spaces to find out what's plugged into network, and then doing port scans and things like that to work out what services are potentially exposed and what vulnerabilities are there. It has some use cases in the cloud, but they tend to be limited to some of the more traditional compute type assets that we see in the cloud. So things like virtualized Windows and Linux systems. Once you kind of get below that into the typical cloud infrastructure, So things like those S3 buckets, those storage containers in Azure, those Dynamo databases, RDS databases, Lambda functions, you know, the list goes on, right? And that's just some of the AWS stuff off the top of my head, right? And then all the Azure equivalents and the GCP equivalents. And before you know it, there's a list of 300-400, you know, different cloud services all these providers have. You don't really have the concept of scanning those. It comes down to the cloud shared responsibility model. So with the cloud, you've got, when you're spinning up things like virtual compute instances, Windows and Linux systems, for example, you are responsible for the configuration, the management, the patching of those, right? Just the same as if you've installed a Windows box in your home or in a corporate, you know, environment. And we all know the stats, right? If you put an unpatched Windows box on the internet, you know, it will be compromised within about 10 minutes or something, right? There's lots of studies around to talk about that. So the point is, it's only really in the more traditional compute layer, which is well understood from a vulnerability management standpoint, is where you have responsibility for actually patching that thing. Once you get down into the cloud infrastructure and a platform as a service, and those lists of services that I just mentioned, you know, as customers, users, you know, you are not responsible for the patching of that, right? That falls under the ownership of the cloud providers. And, you know, they're not perfect, right? The vulnerabilities do occasionally pop up. There were some fairly well publicized Azure kind of container escape vulnerabilities, I think last year at some point, right? So the cloud providers, whilst they're not perfect at managing the underlying infrastructure, they're not bad, right? They're pretty good, though, to be fair, when you compare it to what we as organizations, right, and, you know, some of the customers have done. And when you look back at some of the traditional security breaches, I worked at RSA with Bernard and I were at RSA, right, when that breach happened there. I mean, that must have been 15 years or so ago, right? And, you know, they were a security company, right? And they were compromised on-prem, you know, very traditional things, right? You know, they suffered a big breach there. So that just goes to show, you know, companies like that were getting breached, right? It was a big problem for, you know, for everyone. So in the cloud, we now don't have responsibility for patching these things, but configuration becomes the new vulnerability, because you are responsible for the configuration of these things. It is your responsibility if you create a storage S3 bucket, if you create a database, you have settings within the cloud, access control lists, and lots and lots and lots of settings that you are responsible for making sure those things are configured securely. And a lot of that now can be configured via infrastructure as code technologies such as Terraform, CloudFormation, Azure Resource Manager, Kubernetes Helm charts, right? That is, as you know, the beauty of the cloud, right? The days of long-winded procurement processes and buying physical servers are long gone. Now, you know, developers are responsible for spinning up the infrastructure as well as the application code, right? So all of this stuff lives in traditional source code repositories, GitHub and GitLab and Bitbucket and things like that. And it gets updated and pushed out very, very quickly. So that means that we need to have visibility of our cloud configuration to answer some of these questions. You know, do we have multi-factor authentication enabled on S3 buckets? Are we using public IP addresses? Do our cloud security groups have unrestricted ports open? These are just a few examples of the types of cloud configuration issues that we need to be aware of. So, you know, whilst this kind of new cloud model has enabled us to do lots of these things at speed, it's also a great opportunity to do things differently as well, right? Because because everything is configured as code and is automated and orchestrated, you know, you saw that example of that Terraform code in an easily readable format, you know, it gives us the opportunity to identify security misconfigurations and violations before these things actually get pushed out into production, right? So surely that's better, because it's much better to not have the issue, but it also, from a remediation standpoint, and again, you've all probably come across examples where if a security problem gets out into production, how long does it take to remediate that, right? Once something is actually running, if we find that problem, not only do we have risk, but then, you know, remediation can potentially take days, weeks. It takes a long time to fix it. Versus if we can identify the issue before that thing gets out into production, it can generally be fixed much, much faster. So Tenable released, we made an acquisition of a company called Accurix at the end of last year, and integrated that into our Tenable.io SaaS platform, and released a product called Cloud Security at about a month or so ago, actually, early February. And if we look at kind of a very, very simplified life cycle, you know, starting on the left-hand side with developers, with source code, and then kind of like moving through a traditional CI/CD pipeline, and ultimately that application winds up running in a cloud provider at some point. You know, we touch the, I'm going to let that build, actually. I didn't realise that had so many builds on that slide, actually. So what I'm actually going to do is just, I hate slides like this. Right. Yeah. Actually, no. Should have checked that. Somebody else's slide. That's all right, we can talk through that. That's fine. So let's go back. Right, so we will talk about, you know, typically a developer will use something like Visual Code Studio integrated with something like GitHub or GitLab. This is where they're performing their development, they're creating their application code, and also now the infrastructure that supports that, right, is codified as part of that as well. So we have some integration with we have Visual Studio plugins, which we can have a look at. We'll do a bit of a demo as well. We can basically enable the developers to be able to scan their source infrastructure as code right within their environment. The idea here really is to try and catch these misconfigurations as early as possible. But we also need multiple places to catch that as well, because it can be difficult to get developers on board in order to do that. I was speaking to a customer, big global customer in the UK, a bank, you know, and they outsource a lot of their developments. They're like, well, we've got tens of thousands of developers that we outsource this stuff to, so we can't possibly get them to enforce them to have this within their development IDE. Okay, fine, makes sense. Which is why we have multiple points to catch this. So we can also integrate in with the source code management tooling. So that's the things like GitHub, GitLab, Bitbucket, Azure, DevOps, etc. We can integrate in at that layer via the standard APIs. So we can basically clone the repos out of there and pull those into our platform and look for misconfigurations at that level as well. Again, in some organizations, getting visibility of where all of those things are can be challenging. Again, same global bank I spoke to. You know, the security team struggles to get visibility of all of the repositories that people are using. But what they do, however, have was visibility into the pipelines. So they didn't necessarily know where all this stuff was coming from, but they did have visibility of this code in the CI/CD tooling pipeline before it got into production. So again, we have points where we can touch in and we can integrate there, and we can look at the infrastructure as code there. We can also look at Docker container images, the source images of vulnerabilities at that point as well, to look for vulnerabilities at that layer. Oops. So remediation can also be done here at this layer as well. Because everything is codified, we have visibility of the source infrastructure as code. You don't, in the cloud, very often, the model is to have immutable infrastructure, right? In general, right? Not it always happens that way, right? But general best practice, right, is if you have a problem, you need to fix something in the cloud. You generally don't fix it in the cloud, right? You go back to the source, fix it there, and then redeploy. I caught one of my colleagues earlier, mentioned Netflix, right? That came out of that presentation. But though that they're referenced a lot, right? They're a very, very mature, DevOps organization. They've been in, one of AWS's biggest customers for a long time, right? And they have this whole concept of, architecting, around failure, right? They expect things to fail. And one of the ways that they do that is because they just monitor for problems, right? And when something pops up, you don't try and fix the problem. You go, there's something over here isn't working, right? Let's just get rid of that and redeploy it again from scratch, from a known good state. So that's the model here. So the point is, when we start talking about remediation, the technology that we acquired had some capabilities to create code fix recommendations. So if we've seen some Terraform code, that Terraform code example that I showed before, that had maybe that S3 bucket was wide open. If we identify that in the source code manager, for example, we can, through a pull request, say, here's a suggested fix to that. So we've identified a problem. Your S3 bucket is public. That violates generally accepted best practice. We suggest that you have this piece of code where that is set to true, right? So we talk about remediation as code, and we believe that that is the way, the best way to remediate this stuff in the cloud world. So, I'm going to hate those slides. So, what that enables, the other thing that this enables us to do is we can start talk about drift detection. So, in as well as monitoring the source code or the source infrastructure as code, we also monitor the runtime state of the cloud as well. This enables us to set a baseline, a known good baseline. So it's a point-in-time snapshot of a cloud environment. That then means that should that cloud environment change at a later date, we can identify that and we can flag an alert on that and to say something has changed in that cloud environment. It might actually not even be a potential security violation. It might just mean that something has changed that you want to be aware of, because maybe something has changed in the cloud. Maybe somebody did make an out of pipeline change to the cloud, which again, I know shouldn't happen, but does sometimes occur. This also enables us to do, because we've got visibility of the source infrastructure as code, we can map the source Terraform code, for example, to the running cloud resources to do what we call code to cloud drift. So in this example, we can highlight differences where the source Terraform code says that something should be configured in one way, but the running cloud, again, for some reason differs. Okay, so why is that? Again, doesn't necessarily even need to be a security violation, but why does the running cloud differ from the source code? So this is probably one of our kind of key differentiators, right? I'm going to say who, but at this point in time, there's only 2 vendors on the market with the story, right, of end-to-end infrastructure as code through to runtime monitoring. There is another vendor. They are a big, well-known company. I'm not going to say how they are, but there's only one other vendor doing that today. Lots of companies are talking about it, I'll be honest as well, right? But there are only 2 vendors with the whole kind of end-to-end infrastructure as code through to runtime and the ability to map it all together with a solution at the moment. So what that means, very high-level overview from kind of a general, holistic, Tenable perspective. I've been talking about this platform here, Tenable CS Cloud Security. But the point is, we have solutions that cover most of the stack now. Our traditional experience with virtual machines, operating systems, databases, some of those things that I touched on earlier that we can scan with our traditional scanning capabilities. We've now got agents that run on Windows and Linux systems. So we got pretty good coverage of the compute layer. We've got good coverage of the cloud layer now, and we have a web application scanner as well, which is the traditional dynamic application security testing tool, which can look at the web application. So the message here is from pointing a scanner at a web application, we can scan that, and then we can look at really all of the underlying infrastructure, all the way down to the infrastructure as code. We don't do the actual application code, right? We're not playing in that static code analysis space, the actual Python, Java, that type of stuff. There are a number of vendors obviously playing in that space, and that isn't the space that we are playing in, but we're looking at kind of everything else, right, around that. So a takeaway for you today, we do have an open source offering, pretty easy to find. Just Google Terrascan and you will find it. The URL is there, runterrascan.io. You should be able to find that. Hit me or any of my colleagues up if you can't. And again, in a very similar open source to commercial model, right? It is a basic command line driven cut down version of some of our enterprise tooling. But, this is actually pretty widely used in the infrastructure as code scanning space. And I can show you an example of, kind of how easy this is, to use and to run. So I have a screenshot here, an example output of that, but I've actually got that running here. So I was going to jump into a quick demo. Are there any questions at all before that? Yeah. Yes, you can. Yeah, I'll come on to that. Great question. I'll come on to that. Yeah, there's a pretty extensive out-the-box library, and you can add your own as well. Yeah, absolutely. Yeah, good question. So let's touch on the open source thing quickly first. So as I said, you can something you can run, something you can go and play with today, tomorrow, no cost, right? And have a look at. So I've got in here. I've got some very, very simple Terraform code. It's all it's an Azure security group, an Azure secure storage container. It's not a huge, right? It's very, very basic, right? But it's just a command line, right? And we can just run a Terrascan scan on that, and then it comes and tells me that there are 3 violations there: 2 high, one low, and we've got public access to a storage container. There's a security group that is allowing port 22, SSH, open to the world. And you see that basically just ran through that code really quickly, and it just went through it. Worked out when it looked for all the Terraform, all the .tf files in that, in that directory, and then just analysed those against our policy engine and spat out an example output there. You can tweak the output as well. You can have that come out as in a sort of a human readable format like this, or in JSON or CSV, and maybe something else as well. But you can tweak that on the command line. Again, another example I've got is Kubernetes. I pulled this off of, this is a deliberately vulnerable set of Kubernetes Helm charts. Kubernetes GOAT. I think it's fairly well known. There's a ton of these vulnerable apps that you can pull off public repositories these days, right? In lots of different spaces. But again, I can run Terrascan on that, and that's actually got a lot, right? So there was 244 violated policies in total there, 37 high, 161 medium, 46 low. And again, you can see some of the kind of examples that's done. That's basically just recursively gone through all of the directories underneath there, found a whole bunch of Kubernetes YAML files, and then gone through those YAML files to look for, again, well-known Kubernetes violations. So to answer your question around the policies that drive all of that, signed out of still connected to the internet. Timed out whilst I was talking. Okay, cool. So policies, we've got 1,300 plus policies out of the box. We support the 3 major cloud platforms and Kubernetes. You can easily go and search through this. And if you search for S3, for example, it pops up all the things about S3 buckets. If we click on any of those, we get some high-level details about the issue, the solution. We also map these to well-known best practice frameworks. So things like in there, SOC 2, ISO, NIST, etc. Most of these compliance frameworks will say the same things. It's a really silly idea to configure storage to be wide open, right? But it just means that you can then filter and query at a later date and say, well, actually, the impact of, if we have any things that fail this check, the impact is we are potentially not compliant with some of these well-known frameworks. If people really care about compliance these days, it was a big thing about 20 years ago, but now it's maybe France. It's big. I don't know. Yeah, GDPR. Yeah. We don't care about that in the UK. We're not part of the EU. Yeah. Why would we care about it? No, compliance in the UK is a bit strange. It's not. It's really not a big. It's really not a big thing for us. So talking quickly on the other thing we'll touch on is, again, so there's an example of a Visual Code Studio plugin where we have some code, a security group here allowing wide open SSH access on port 22. Right, I can actually, we have a plugin that actually enables us to run that scan directly in the Visual Code environment. So again, really just to provide that feedback, directly back to the developer within their environment. Hey, let's just allow them, if they want to check their code against that list of policies. We'll come on to the custom policies actually as well. Custom policies can be created as well. So we'll allow them to check their code against that in that environment. Add custom policy, add policy. So again, spoke to same large bank yesterday we were speaking to about this one as an example, AWS instance. They have a list of authorized AMI types. sorry, it's AMI. No, it's not AMI type, actually. It's not AMI. I'll show you some of the values that all comes into, but there is I thought there was an AMI type in there. No, IAM is the identity. It must be AMI, actually. It is AMI. AMI equals. I'll show you what that is. The idea being that they had a bunch of authorized AMI types that they'd been through a certain amount of testing. Basically, they didn't want DevOps people spinning up AMIs off of, out of the some of the marketplace AMIs, right, in AWS that hadn't been through a testing process. They had within their environment, they had a big long list of corporately authorized AMIs that had been through some other tests prior to this, and they only wanted people to spin up instances based on that. So we showed them how they could create custom policies to say, we only expect certain AMI types to be used. So that's one example. So custom policies can be created. And if we then look at an example of AWS running cloud, and I've got an instance in there, and the idea is that when we query the running cloud, first of all, we can say, hey, there's some failing policies on that instance. It's allowing public IP address. It's got IMDv1 disabled, which is a pretty major issue. But we pull the details from the running cloud via, in the AWS world, a read-only IAM role, a read-only application service principal pair in Azure, whatever the equivalent terminology is in GCP. We basically need a read-only API role within the public cloud environment to be able to query the running cloud. We pull that data back. We then normalize that into this JSON format, and that's actually the value that I was looking for. Actually, is AMI. So I thought for some reason I thought it was AMI type, but it's AMI. And then there's every AMI type has kind of a unique ID, right? But on the AWS back end, you can't really see it in the API actually. But if you were to go and look in the AWS console, you could map that back to Amazon Linux or Windows or some custom thing, right? But the idea is that each AMI type has a unique ID. So that was the value that this bank wanted to use in their custom policies, to say, I've got a big long list of these, and I only expect to see those being used. So we can create a policy to say, this is what we expect to see. So if anybody was to spin up an instance that wasn't using one of those, it would be a violation of that policy, and it would get flagged as a failing policy like this. So we can create those. It talks a little bit about running cloud, some examples there. We also have the ability to tie into repositories. So again, I have an example. There's an example, Azure DevOps. I've got some GitHub stuff in there. It's all very, very similar. Again, we're just using the APIs to connect to public cloud repos. If you have an on-premise GitHub or Bitbucket or something repo, sat within your environment behind a firewall, we have what's called an on-premise scanner. It's basically a virtual machine that you can download. You drop that into your environment, and then you then configure that thing locally to connect to your local repo, and then that VM just needs outbound connectivity to our cloud platform in order to send the results up and then to communicate with everything else. But here we see infrastructure as code. So here we see resources. With all of these things, the idea is it's the same set of policies that can run against a running cloud config and can also run against some infrastructure as code as well. And you can then look at it in two different ways. You can look at it from like the resource standpoint. So we see, there's the resources that have been identified in that infrastructure as code. provides you visibility into this. There's no failing policies on these ones, but you can still drill in and see these security groups and see the actual configuration of that. So there's a visibility thing there, a visibility message there, but then there's also the ability to go and see the violations as well. We can also look at it via the other kind of view, which is by violation. So that within that code, there are actually 4 violations, and there are the 4 policies that are being violated there. You can drill into those and say there's kind of the Azure version of your public S3 bucket, right? A storage container not set to private, which basically means it's open. So you can drill into that and see the details of the resource that has failed that policy. From a Kubernetes standpoint, I have again, we support Kubernetes in the 3 major cloud platforms. So GKE, AKS, and then that leaves AWS, doesn't it? ECS or whatever. Well, they've got a couple of different versions, but we support the cloud managed, the 3 major cloud managed Kubernetes environments and traditional on-premise Kubernetes as well. Again, we have a local agent, for want of a better description, that can be dropped into an environment. I ran that on my laptop. I have just the Docker desktop, Kubernetes cluster running on here, which I can just run that local scan on my laptop against that. And that is my Kubernetes cluster here. And then you drill into that, and you see all of the resources, and all of the all of the violations there. So there's an example of that's just a completely default Kubernetes configuration on Docker desktop, so it's definitely not going to be locked down. But the point is the same, right? On a default out of the box install of this stuff, you do need to go and lock it down. And there is a big long list of things. I think the USA, the NSA, CISA, they released an update to their Kubernetes best practice hardening guide. Yes, in the last few days, I saw something ping up on my Twitter feed, and I haven't looked into it yet. But the point is, this information, how to harden Kubernetes, is out there, right? You can go and find it, but you will get a huge document, several 100-page PDF, to trawl through. There's all the AWS, best practices, well-architected frameworks, all of this stuff as well, right? All that information is out there in the real world. Feel free to go and download all that documentation and manually go through all your running cloud config and all of your source code. Absolutely. But it's just not scalable, right? You would need an army of people, and even then, you'd be struggling. You've got to automate this stuff. That's the point, right? So what we're doing is we're automating the checking of all of this stuff, and we're owning kind of the putting together of all of the policies, the best practice frameworks, so that you can then just run this against your code and your environments, right? So we looked at Kubernetes, and then I also have, that's the running cluster, and then there's also that's the Kubernetes Helm stuff. So again, that's what I pulled down. I ran the command line scan against that, right? And then that's the command line, the free open source one, just gives you basically just a command line output, right? But obviously the enterprise version is the one that allows you to get in here, do reporting and analytics, and look at the data in all of this kind of view. Sort of drawing to a close, actually, finally, and of course the big value is, and then are there other tools that do some of this stuff? Yes, right, okay. But the other thing that that Tenable do, right, and is we bring all of this data together into our platform. So this is what I touched on with one of the slides where we cover the whole stack. There is a Windows vulnerability on a compute instance. Again, if you've got any kind of a hybrid environment, right? I mean, I don't know. Obviously, there are lots of new startup companies that are, completely cloud, right? But for anyone that's been around for, longer than 5 minutes, customers will have, hybrid environments. They'll still have on-premise infrastructure. The big banks and any company that's been around for 20 years, is still going to have a huge on-premise infrastructure. So our message here is that, we have a lot of experience of scanning that traditional infrastructure. So you can have all your traditional data in here. This could have come from this could be a Windows system running in the cloud, or it could be a Windows system in an on-premise data center somewhere. We can give you that visibility of, hey, that's missing a patch. Here's the risk, the solution, the remediation steps, etc. We give you that, alongside web application vulnerabilities, don't have any of those in this environment, and cloud vulnerabilities as well. So everything is all in the same platform. And then the message there is, a centralized reporting and, dashboards and, and analytics and all that kind of good stuff. So you can then get the right data to, to the right people. Integration with ticketing systems, with ServiceNow, Jira, with SOC, SIEM, type platforms as well. So this data can be used and consumed by other tools and other processes. That's everything. So I'll answer any questions if anyone has any. Thank you. Yeah, so that's a great question. So yeah, I'll show you how it's done actually, right? And that might well answer the question. So yeah, when you go in and create the snapshot here, you've got the option to set a baseline here. So yeah, you could quite easily set a insecure baseline. Yeah, so there is an element of you've got to. We're not stopping you configuring an insecure baseline, right? So I could set a baseline on. I can see here there's a running cloud configuration there, with a whole bunch of bad stuff, right? And I could set a baseline based on that. So no, there isn't anything to stop you doing that, right? So there is an element of you got to use this in the right way and get things fine-tuned down to a reasonable level before you do that, yeah. What do you mean by a baseline of baselines? So, right, so you got, yep. Yeah, so we have this concept of what we call projects. So within each project, there is only one baseline, yeah, but you can have multiple projects. So you could have, a project might group together particular applications that might group together a particular set of infrastructure as code, a repository, and maybe a single VPC. So you can focus it down a little bit. We'll talk more about it offline. But the idea being that you can have multiple projects, and they could overlap as well, right? So you could have a project that is 2 projects, and each one is maybe touching on some of the same resources, right? Each project has a baseline, so that's kind of the way that would work. Yeah. Okay. Cool. Great. Thank you.